Awesome. Well, apparently we are running a little early, so we're going to go ahead and get started with the Advanced BGP using route reflectors. And this is a presentation that I've done for several other shows, and I think it's a pretty good presentation. I hope everybody has some questions. And really it's about how we break my projector, apparently. There we go. How we do and how we can block denial of service attacks by using BGP route reflectors. Now this is just one way. It's not necessarily the only method that we use, but it is a method that we use to, especially whenever we have a lot of BGP peers and we have a lot of core routers. So again, my name is Dennis Burgess. I'm the CTO with Link Technologies. We do advanced WISP support, engineering work, router OS work. We sell router OS. We sell all the MikroTik products, Ubiquity, Cambium, pretty much the entire product line that any WISP would need as well. Our contact website as well as our phone number is listed right there. So let's kind of go over some basics. The very first thing is we have two different flavors of BGP. One is external BGP. How many people here use BGP to connect to their peers? Some, okay. And maybe, make sure my cable's plugged in. External BGP is basically a BGP peer that has a different AS. That's really it. We also have another form of BGP that we call iBGP, and this is basically a peer that has the same AS, or the same autonomous system number. This is typically used when we do cross connects. So if we have 2 or 3 or 4 CCR 1072s and we wish to interconnect them and distribute all of our BGP, we would use iBGP to do that. Again, there's really no additional configuration in iBGP. It just has the same similar AS. That's it. Now, what is a route reflector? In our case, we typically put a small router board. We've used CCR 1009s. We've even used 2011s. Okay? What these are is these are typically a command and control router board. So we do a iBGP session from our little bitty router board. We've also done CHRs as well. And that unit then does all of our command and control for our BGP sessions. And I'm going to get to that, how that all works here in a little bit. Typically, though, you're going to need 2 of those because you need to have redundancy. Something else that we have used these route reflectors for is we actually do all of our advertisements on a centralized route reflector, so that if our iBGP session goes down from that centralized route reflector and it goes down to our edge device, now our edge device stops announcing our prefixes. And that can be helpful in some cases and it can be detrimental to others. So you have to have very specific examples of needing that. Again, as I said, we have used small CHRs, 2011s, etc. Now what we do is we configure our routers and filters accordingly. So let's say I want to block a BGP, a denial of service attack. Well, one of the things we do is we actually have black hole servers. How many people in here, out of all the people that had BGP sessions, how many people have configured their black hole communities or black hole servers? 3 or 4? Okay. Most of the time, you will have a BGP guide. So if I go to AT&T and I say, hey, I need to do black holing, and what black holing basically does is it basically takes one of your internal IPs, one of your public IPs, and takes it offline. It will black hole all traffic coming to that IP before it gets to you, which allows you to survive a denial of service attack. But what we do is we ask them for a BGP guide, and it depends on the different companies. Cogent, how many people in here have Cogent? Quite a few. Cogent uses black hole servers, so you'll actually set up a separate eBGP session that's eBGP multi-hop to their black hole servers. AT&T, they have their BGP guide, and they have just a community string that we can send. And basically we say, hey, here's this /32. I wish you to black hole that coming into your network so that no more traffic comes in to my network. And we typically use this when we have, again, a denial of service attack that is overflowing your pipe. So this is the BGP guide. This is just the little section of the Cogent Communications guide. They give you the North American and Asia Pacific peers, where you can peer with those. It is free to get a black hole server peering with Cogent. You do have to request it though. You just send an email to support@cogentco.com, say your AS, hey, I need to BGP peer with your black hole server, and they'll set that up for you very easily and quickly. AT&T, you're going to be in that for about 2 weeks before that actually might get set up. They're just not very quick about it. But there's other companies, like we have Zayo, we have Level 3, all these companies offer black hole servers, or they offer a black hole community string. And the big thing is, I always ask, where is your BGP community guide? Where is your BGP guide? You, as an ISP, can also create your own guide. How many people in here do AS transiting? In other words, they pass another AS through your AS. Okay, so you guys also should have a BGP guide. That is my recommendation. It doesn't have to be big, but you need to list the community strings. You need to sit there and state, hey, we will advertise, if you send this community string, we'll advertise your prefixes out, provider A, B, and C, but not D. All those types of things can be done, and all you have to do is create it. There is not really a standard on which BGP communities you wish to have, but you do need to create that, and you need to set your standard for that. And there are a few guides that you can use that you can actually take and basically copy. It's perfectly fine to do that, but there's really no set standard in that. Again, I also use these CRRs, is what I call them. These are centralized route reflectors to advertise the prefixes. And the reason why I do that is we have had very specific instances where we have a BGP edge way over here at a data center. And then we have a layer 2 transit coming way out to the actual ISP. Well, one of the things that I need to do is I need to actually withdraw my announcements when that layer 2 transit goes down. Why? Because I don't need those announcements. I have another BGP peer that I actually need those announcements. So I want to put the actual router that's actually announcing my prefixes as close to the core of my network as possible, not out on my edge. And that's why I use the centralized route reflectors, is that I announce those prefixes there, and if anything happens to my layer 2 connectivity back to my data center, all of a sudden that router, it'll still be connected, but it will withdraw all of the prefixes that I actually had. Something else you can do with a centralized route reflector. How many people participate in the Team CYMRU? I think I'm pronouncing that correctly. They're Bogon lists. I do. It's a very good way to ensure that you're only passing traffic that you need. You can get a free peering session with them. They have Bogon servers all over, and they will give you all the IP addresses that should not be on the internet. There is also another service, I believe it's by Spamhaus. This is actually probably one of the better ones. It's actually a paid service. It's not very expensive, but you can actually get a list of IPs, and there's I think about 6,000 IPs on the Spamhaus list currently. But what that is, this is all these command and control IPs for botnets. So how many people have a problem with botnets? You have people sending out viruses, people sending out traffic on your network. You can actually get this Spamhaus list, apply it to your routing table, and black hole any of their command and controls for the botnets. So now, even if their computer gets infected, it cannot get back out to the botnet command and control system, therefore it doesn't work. Make sense? So that's also another service that I'd highly recommend. So let's kind of do some little slides here, little images. So this is a very common example of using a central control route reflector. We have multiple peering boxes that we peer with. We then have a central route reflector or two, and then we have our core network inside. Again, the route reflector does not have to be directly connected to your edges. You can put it on maybe it's at your office where you have layer 2 connectivity back to the data center. Again, it does not have to be directly connected because you can do BGP multi-hop with that. But the whole ideal is, again, you want to announce at the most core location that you can. Otherwise, you can do a synchronization. Anybody ever use BGP synchronization? So if you go to BGP networks, there is you type in your network, your prefix that you wish to advertise, and then there's a little box that says synchronization, yes or no. Well, what the synchronization does is it takes the internal routing table, okay, anything learned from IBGP or OSPF, and it looks at that, and if any IP addresses are in the prefix that you're trying to announce that are being learned through an IBGP or through your OSPF session, it will keep that network and advertise that network. If you say yes, that synchronization yes, as soon as those networks drop out, so let's say you have a /24 that you're announcing and you're using OSPF as your IGP, soon as that OSPF drops, so your OSPF, your layer 2 link drops, now you do not have any IPs inside OSPF for that /24. Well, then it automatically withdraws that prefix because it can't get to anything on that subnet. So that's another way you can do it. I like using route reflectors because that actually gives me more control. Something else you can do is, based on your BGP guide, whatever you decide, you can actually sit there and say, hey, I wish to advertise to provider A, but not provider B. And you can just simply put a community string in. So again, you can put all that data into the route reflector. It sends that data to both of your edge routers, and then your edge routers, based on the communities that you've set up, it will do exactly what you say. Now we're only going to advertise this /24 to provider A and not to provider B. And then you can also give your customers that BGP, that same community string, that BGP guide, and they can affect their routing as well. So in this particular case, we have, again, I kind of mentioned a lot what I've just talked about. This is the slides here. I usually don't read my slides, or I try not to. But this works extremely, extremely well. And again, it does not have to, you do not have to exchange full tables with the CCRR. That's not the goal of this particular route reflector. The goal of this route reflector is to command and control your BGP sessions at your edges. Okay, and those edges could be diverse. As I said, you could have 4 or 5 edges all connecting back to one route reflector, and then you can sit there and advertise whatever you wish to, or do a denial of service attack prevention by using your route reflector. So how many people in here have been denial of service attacked? And how many people survived that attack? Okay, so did you survive it by using a black hole, or did you just have route filters, or did you just have a firewall? Anybody? Gotcha. So you used a black hole server or a black hole community to black hole the IP that was being attacked. So there's really 2 stages of surviving a denial of service attack. The very first one is having enough bandwidth to sustain the attack. That is probably the very best thing that you can have. I'll tell you right now that if you go to Cogent or AT&T and you, let's say you're looking at purchasing a 1 gig circuit, and you tell them, hey, by the way, since I'm going to get a 1 gig port, how about if you just upcharge me a little bit, give me a full 10 gig port, and give me a 1 gig commit? Most of the time, they're going to do that for free. So all of a sudden, you're going to go from buying a 1 gig pipe that's limited to 1 gig, and now you have a 10 gig pipe that you're only paying for a gig service because that's what you've committed to. But if you get the occasional burst, it's not going to really affect your price. It's only it's usually billed on a 95th percentile is what they usually do. So if you commit to 1 gig, you pay, let's say you pay $300 for a 1 gig circuit, and you have a 10 gig port, you can sustain a lot more in the way of denial of service attacks. Then the second stage is not enough bandwidth. I'll tell you right now, most of the denial of service attacks that we see are caused by one type of user. Can anybody tell me what that type of user is? Gamers. We had a company that they came to us and they said, we're getting constantly attacked. Our routers are going to 100% CPU. We can't even log into them, and it's causing havoc. And we ended up tracing it back to a single gamer playing League of Legends in competitions, and they would sit there and the competition goes, hey, if I can lag that person out by flooding their connection, then I get a $10,000 prize, because that's what the prize is to win on some of these games. So it's absolutely critical that you know where your denial of service attacks are going. And eventually they just fired the customer and said, hey, we're not going to deal with you anymore. And then the customer has to go to a gaming center now, I think. But basically, whenever you don't have enough bandwidth, okay, let's say you have a 1 gig circuit, most of those denial of service attacks are going to be over 1 gig. But most of the denial of service attacks that I see are under 10 gig. There are definitely much, much, much larger attacks. I think the world record is like 1.3 terabits is a denial of service attack that just happened on Cloudflare's DNS servers. But most of the attacks, whenever you get gamers playing, these guys aren't going to spend a whole crap load of money to do a denial of service attack. They're putting $5, $10 in to try to make, you know, $1,000. So because of that, most of the attacks I see are anywhere between really 800 meg to about 5 gig. I'm not going to sit there and tell you that that's going to be normal, but that's most of what I see. So when you have enough bandwidth to sustain the attack, it's very simple. You just put firewall rules on your edges to detect the attack and then block it. Now, there's 2 ways you can put those rules in. One, you can block denial of service attacks coming in based on source IP. Okay? Now, this will keep your customer online. Okay? They can still go to websites, things like that. You're just saying, hey, I see 20,000 packets per second coming in from 30 IPs, and I've identified them as a denial of service attack, and I'm just going to block them on my edge. Again, it hits your edge drops it, your CPU will spike up a little bit, but you have enough bandwidth to survive the attack. And let's say that was a 300 meg attack. No big deal. All right? My big key here is on these edge devices. So if I go back here to the images here, on our peering routers or our edge devices, do not run everything on an edge. So the client that I was talking about that they were having these CPU issues, they had QoS running on it, they had NAT running on it, they had connection tracking running on it, they had a whole suite, you know, 800 firewall rules, they had 300 or 400 queues, they had a whole big mangle system. And that is where, I hate to say it, RouterOS kind of fails. One of the best things about RouterOS is it does everything. One of the worst things about RouterOS is it does everything. And in those particular instances, you need to limit what you do on your peering routers. Turn off connection tracking. Turn off all the services that you don't use. If you just use Winbox, then guess what? That's the only service that you should leave on. If you have SSH, leave it on, but make sure you firewall that from the outside world. You have SSTP VPNs. You have VPNs that you can do on the inside of your network, but those edges should be very, very basic, okay? And that is, keep in mind, if you turn off connection tracking, you can assume that that device can sustain twice the amount of data coming into it just by turning off connection tracking. You turn off queuing, you turn off all these other things, now you have a lot more CPU to do more with. You can block, you know, so we were getting like 5.8 gig attacks that was being blocked at our edge, and everything works. Everybody's perfectly happy. You can do that with CCRs. We do it all the time. You just have to design it and scale it correctly. All right. So, if you have enough bandwidth, you can rely on your router to block. There's no point in doing anything else, such as black holing. Why? Because that black holing of that IP would take the customer offline. And in many cases, that's perfectly fine if you take the customer offline. It really depends on how much bandwidth you need and how much bandwidth they're attacking you with. So if you have a 1 gig circuit and your average traffic is, let's say, 600 meg, and you get a 200 meg denial of service attack, you may or may not wish to black hole that because you may need a little bit more bandwidth. But that's your call. So now let's talk about when we're out of bandwidth. This is the goal of denial of service attack. They want latency high. They want the customer to basically go offline. And black holing should be what we consider a last resort option. The reason is it literally takes the customer offline. If you have a bank website or something like that that's operating on your network, you need to be able to sit there and take that denial of service attack, block it at your network edges, and then keep the customer online. Hopefully they're paying you well to do that, and maybe you might need to reinvest in your network to be able to do that as well. But if you are getting a denial of service attack that has so much data that it's filling up your pipe, now you need to black hole. This is what I do. I have my command and control route reflector. Again, it's a little 2011, but the difference is that that data is not passing through that 2011. So guess what? I can log into it. Has anybody ever tried to log in with Winbox to a router that's getting denial of service attacked and the CPU's way high? A lot of times it doesn't even work in some cases. So in these particular instances, I log into my route reflector and simply type and advertise a single /32 into my network statement. So what does that do? That, of course, takes the customer offline, but it actually sends the BGP update to all of my edges, and then all of my edges already know how, based on my filters, know how to advertise that individual IP address to my upstreams. So immediately, within a few seconds, all of a sudden, all that traffic stops coming in, not on one interface, but across all my eBGP edges. So that's one of the other reasons why I like to use a command and control router by using iBGP, because I can log into it and I can actually send an update through the existing connection. I don't even have to log into my edge routers to make that change. Any questions? Everybody's looking kind of glazed over? Awesome. Whenever you do a black hole, you do have a choice. You can sit there and let that customer run, but you may have an entire network mad at you because you're out of bandwidth. Again, it's your choice. It's your network. You can do whatever you wish to, but I typically choose that if I can take one customer offline, I'd much rather do that than have a whole bunch of customers pissed off at me because their latency's high and their network's slow. So the comment was he had a customer that was sending out a denial of service attack from a single IP. When they contacted Cogent, Cogent wished to black hole the entire /24, not the individual IP. Typically, the black hole servers with Cogent will accept a single IP. Okay, or a /64, I believe up to a /64 in IPv6. We always advertise a single /32. My assumption is you did not have a Cogent black hole BGP connection? I'm sorry? No, not prior. Okay, so the Cogent should have offered a single IP to black hole. Why they didn't, I couldn't sit there and tell you that. I have dealt with Cogent. Usually they're pretty on it, but obviously maybe the tech that you had was not on it that day. But now that you have black holes, you need to have your black holing servers, or you need to have these policies in place before you get attacked. Because if you have these policies in place, now you control your fate. You can simply say, hey, this 1/32, I'm going to advertise, it goes off the face of the net, and guess what? Everybody's happy. The difference is you are in control of that, not somebody else. And that's why I would always recommend request from your ISP, where's your BGP guide? How can I black hole? That's one of the first two questions I always ask any upstream carrier that I'm dealing with. And the reason for that is exactly that. How many people are on IXs, so Internet Exchange Points? Most Internet Exchange Points, you can sit there and send to their route reflectors a black hole. They typically have a black hole community. So that's also another big factor is that you can, again, all you have to do is ask them for this. This should all be standard BGP stuff, and more you get this done, sooner you get this done, sooner you have more control over what you're doing. So the question is all of his customers are rate limited, therefore my customers won't be may be maxed out, but I won't be maxed out. It kind of works that way, but not really. So the example is a denial of service attack will flood your network. So let's say you have a 1 gig pipe. If you're doing a DNS amplification attack, right now that is 1 to 53. So every 1 byte of data, they send 53 bytes to you. Because it's UDP, it comes in, and even if your firewall drops it, it's still coming in over that 1 gig pipe. And eventually, that 1 gig pipe is going to get filled. So even though you're rate limiting and even though you're dropping that data, it still has to come across your pipe. Now, are you rate limiting at your edge or are you rate limiting at your customers? Okay, so that's you really should rate limit both at your customer prim, as close to your customer prim as well as your edge. And there are very specific reasons to do that, but in your particular case, as soon as it comes in and it hits that queue, yes, it's going to be slowed, but you still have to take all that data, and because it's most cases it's UDP, because it's UDP, it's just going to flood. There's no response to saying, hey, I'm getting it, so it's just going to keep coming in, keep coming in, keep coming in. All right. So, as I said, we simply add that /32 to our route reflector. It advertises to all of our edges. All of our edges now know exactly if we have a Cogent edge, it goes to the Cogent black hole server. If we have an AT&T edge, it goes out a very specific, we add a community string to that /32 to advertise that /32, okay? We do that because that is what we need to do to get that IP into black hole, and we don't have to log into 8 routers to do that. We just have one central location that we do that on. Make sense? All right, so the big thing though here with your black hole, once you've advertised it and you black holed it, that IP address is offline. They're done. They are not going to do anything. They are going to call you, go, hey, why are we offline? And you go, okay, well, you've been getting targeted by a denial of service attack. We had to take your IP offline to sustain that attack. The big problem we get with black holes is we don't really know when the attack stops. So if you leave it in a black hole for, let's say, 30 minutes, you take it back out, and then the attack comes right back in, well, then you have to add it right back again. So you do have to realize that that can happen. Most denial of service attacks, especially with gamers, are very, very limited. They want to see an immediate result. So if they're going to do a denial of service attack against an IP, they need to see that that IP goes offline or latency increases so much that they are basically can't use it. If they don't see that, then they're pretty much going to stop the attack, because every second they're doing that attack costs them money. So they're not going to sit there and keep doing an attack for hours upon hours upon hours, because guess what? the customer's already off, the customer is offline, or they're not, the attack is not effective, basically. All right, so again, this is kind of the stages or surviving the denial of service attack. And my phone goes off. There we go. So what we have here is we have provider A, provider B, we have a peering AX, and we have an attack. An attack can come from one or multiple vectors. So it could come across our peering IX, it could only come across one of our peers, or it can come across all of those simultaneously. We typically need to understand where it's coming from and how to block it. Again, typically I will sit there and put a, use our centralized route reflector, and I send it to everybody all at the same time. And that's because I don't really need to know where it's coming from. I just need it to stop. Make sense? But normally what would happen is it comes in and then it goes through your peering routers, and then it goes to your core, and then it goes to your customers. And eventually it's going to hit a low bandwidth link, and that link's going to get saturated, and then that will, of course, cause issues. What we typically do is we use a very specific set of firewall rules, very basic, very simple, and there we go, at our peering routers to detect a denial of service attack, depending on which one it is, and then we firewall it at our largest connection point. So let's say peering provider A and provider B are all 10 gig links. If my attack is 2 gig, as long as it's not saturating that 10 gig link, I'm fine. And I can stop all my data at my peering edges, and I can withstand that attack. Make sense? A lot of times we just use address lists. And eventually MikroTik is going to add an easy feature. MikroTik, you're listening, right? To automatically add a /32 to a BGP advertisement, but right now the only way to do that is through a scripting system or through a route reflector. All right. Now let's just say that we have a 1 gig connection on provider B, and that provider is maxed. Again, all I do is I go to our route reflector, I add my /32 of my customer being attacked. That then sends that /32 to both peering routers. Both peering routers then update all my black hole servers, and immediately that attack stops. Make sense? Any questions on how I'm doing this? Everybody's good? Sweet. Everybody's hungry, aren't they? All right. Now, there are several other methods to do denial of service attack prevention. One of these is using a DDoS scrubbing service. I have used these. They do work. They are typically really designed for large-scale attacks. So let's say I have a single 10 gig connection. I subscribe to a DDoS scrubbing service. What actually happens? So I know I have a slide here or a picture here. Basically, what they do is they have a peering router. So let's say I have my peering router, I have a 10 gig link, and then I have my /22 being announced. I guess I could use a laser pointer here. What the scrubbing service does is they actually create a GRE tunnel, and then we send net flow data up to the scrubbing service. Now there's a reason for that, because the scrubbing service needs to know what data is actually coming across our network. And eventually, they are going to detect a denial of service attack. When they do, depending on the scrubbing service, and this all needs to be pre-planned, etc. You need to have all your prefixes, all that kind of good stuff. But let's say they see an attack coming in on one of our /24s. Let's say it's to a single IP. Well, what they then do is they will then advertise, the scrubbing service will advertise a single /24 out. Because it's more specific, or because it's a longer prefix, all of the traffic on that /24 will go through the scrubbing service, and then they will deliver the data, the scrub data, over this GRE tunnel to you. This does work. It does work quite effectively. And then whenever they stop seeing that denial of service attack coming in, then they will withdraw that /24 and all of your traffic will come directly to you. Anybody do this, subscribe to a scrubbing service? Nobody? Usually, there is a con with this. Again, the big one is typically it's pretty expensive because you have to think, if you have a 10 gig link, what do they have to be able to withstand that attack? Basically is the way. You know, they probably have a few hundred gig E-links because they need to sustain that attack and send the scrub data to you. So they need to have enough bandwidth to sustain the attack. Now, there are other services. There's a cloud site. They make little boxes that do 10 gig. They're about 100 grand a box. And they will automatically scrub that service until your 10 gig is saturated, and then you're basically back up to a scrubbing service again. We can pretty much do that now with MikroTik. So I don't know why anybody would buy those boxes, but I do know people that they purchase those core site boxes all the time. So obviously they're making money on it. It does monitor your service and can filter out the denial of service attacks. The scrubbing service, I've seen pricing ranging from a few $100s a month to several thousand. Also, you have to think about this is that they have to actually process all of your net flow data constantly. So they actually have to monitor for the denial of service attack on your network. So they actually have to have enough CPU to do that. And if you have a 10 gig or multiple 10 gig links, it can actually add up pretty quickly as far as the cost on that. Now, we have one other method that I have used in the past, and this is what we call a NetFlow BGP monitor. It's very similar to using a route reflector, but basically, instead of you using a scrubbing service, you have a NetFlow scrubbing server. And you're actually not going to scrub anything. What you're going to do is this box gets the NetFlow data, and then upon it seeing that there is an actual denial of service attack, it actually advertises to your peering router the individual /32 that you wish to black hole automatically. This does work. We have done it in the past. You do have to have a decent NetFlow scrubbing server. In other words, it's not going to be a VM typically, because it typically needs to have enough CPU to analyze all the data. But basically, you're just sending the same data that you would send to a scrubbing provider to a local server, and then that local server then issues a individual /32. Now, with this scrubbing service, I usually get a question: why do they have to advertise a /24? Why am I going to send all my 256 customers through the scrubbing service when only one's getting attacked? Well, because that's the smallest size or the longest size that you can actually advertise. You cannot advertise a /26 out on the internet. So a /24 is the the longest block that you can advertise, or the smallest block, if you want to call it that way. So, any questions, queries, posers, or other informational tidbits that I can give on building a DDoS protection system using your MikroTiks? Nothing. All right. Any other questions? So the question is, do we have any scripting that we use? Typically, no. And the reason for that is scripts are fallible. I try very, very hard not to ever use a script in routers. Let me rephrase that. Programming them, no big deal. I use scripts all the time. But I do not want a script that has to run every 5 minutes or every minute on my routers. The reason for that is typically there's always something that I have not thought of. Furthermore, if you have a small router, let's just say you have a 1009 and you're getting 400,000 or 1 million packets per second, how well is that script going to run whenever the CPU is at 100%? Make sense? We typically want to offload that process. So again, using the, if I go back here, using the scrubbing server, offloads that to a scrubbing product, a product that actually understands how to analyze net flow and then understands which subnets are mine so that I can then advertise in a automated fashion. So the scrubbing server is a purchased product that we purchased to do that. I typically don't use any type of automation scripts. They get really complicated really quickly, and I try to avoid that if at all possible. I'm not going to sit there and tell you one. If you Google, and this is mostly just from my consulting side, I don't want to sit there and recommend any particular product. If you Google a NetFlow BGP scrubbing server, there are tons of them out there. There are also other products that you basically do the same thing, and they actually monitor ping times through multiple providers, and then they can actually inject and change your BGP transits based on ping times. So if going out provider A is, even though BGP says it's longer to go out A, but the ping times are shorter, then it will automatically adjust all of your routing table to do that. Those products are not cheap either. They're like $2,500 a month or something like that. But there are, just Google, NetFlow BGP scrubbing, and you'll find plenty. Any other questions, queries, posers? I was supposed to take up more time. Any other questions about anything MikroTik related? I'll take those because we got time. Nothing. All right. Thank you very much. I hope everybody learns a little bit today.